Okay, so the dairy cow potential milk production actually starts as a neonate in its mother's womb. It is developed in the womb, and hence the treatment of the dairy cow carrying developing calf is important to developing the calf's potential as a milk producing dairy cow. So actually many people start looking at choosing a cow to put into the herd as a heifer, but actually the potential of that dairy cow has already been somewhat developed and actually starts as a neonate in its mother's womb. So the treatment of the pregnant cow is important for the future producing dairy cow, and therefore it needs to be understood and known that you need to look after the cow and its calf for your future herd. That's why many of the herds now around the world are actually using sex semen or sexed embryos, and are producing and knowing what the calf is in the pregnancy situation as a neonate. Along with that, actually, cow comfort plays an enormous role with the milking herd, and with their local environment. In other words, the dairy sheds or the grazing areas, the housing conditions. If you have the correct conditions, will have less stress, resulting in optimum reproductive rates, high feeding rates. In other words, they'll eat more, have less health problems, less injuries, and will produce more milk. So it's significantly important that we actually look after our cows and understand that the potential of our milking herd starts with that developing calf in its mother's womb. Next slide. So the factors that influence the dairy cow comfort from my situation, when I walk onto a dairy, I start asking questions and assessing the 24 signs that I have, or the 24 points that I have up on the screen. And look, I'm not going to go through them all individually, but most of the dairy managers understand and know most of these, and therefore it's significantly important that we remind the managers on a regular basis that they need to look at the factors that affect the comfort of the cow, because the comfort of the cow leads to less stress and hence more production. The one that we look at today in more detail in cow comfort is actually intake, the diet, the ration fed to the dairy cow, because actually if the dairy cow is fed properly, it will ruminate properly, it will lie down and rest. So there's many things that are mentioned in the 24 there that the diet also influences in terms of the cow comfort. Next slide. So from the list before, the one that we need to mention very and stress significantly, even though today's webinar has very little to do about heat stress, but no matter where you go, heat stress plays a role, and the dairy managers must take notice of heat stress. Heat stress will influence many things, including feed intake, including the animal's rumination. So there's many issues that heat stress. I just wanted to raise that issue with heat stress will influence feed intake, which will ultimately affect protein in the animal. And perhaps another seminar we can go through how heat stress would affect the diet and the protein levels in the animal. Okay, next slide. Okay, the one that actually is significantly important is chewing the cud, rumination. And as you know, it's the regurgitation of all matter ingested and comes up to the mouth and is mixed with saliva, which actually has a buffering effect and will return back down into the rumen. impacted by the diet's nutritional status and the forages. So the fiber form plays an important role in rumination, and actually in the digestive health of the animal. Increasing the feeding time, in other words, the length of time that the animal has feed in front of it, and dry matter intake has a positive effect on rumination. And a cow will control rumination in response to external stressors. So if the animal is comfortable, in other words, all the 24 points that we mentioned in the few slides before can lead to the cow comfort, being, the cow is very, very happy, there's no stressors, then rumination is a normal process. But if it's not, and cow comfort, if the cow is not comfortable because of a number of those reasons and so on, that will affect rumination. That will then affect digestion. That will then affect milk production, will affect many, many things. So the bulk of time ruminating occurs when the cows are resting in quiet environments and in a comfortable resting place. And that will give rise to good rumination, and therefore hence good cow comfort. Providing environment that is conducive, maximizing rumination, helps to meet the cow naturally ruminate. Now, the optimum normally around about 8 hours for a cow will ruminate every day. And the cows prefer to lie down. And look, there's a lot of information out in the marketplace, out in the research world, talking about rumination and how that will influence the animal. But rumination also affects protein levels in the animal and protein levels in the milk. So it's important that we actually understand rumination plays a role in the digestive process. Next slide. Okay, so rumination, variation in rumination is due to all these factors, and therefore understanding that is very, very important. Now, the blue ones there that I've mentioned in terms of the fiber content, the feeding management, the palatability, and so on, all has to do with the feed and the intake. And included in those points are proteins, and how the proteins are taken into the animal, how they're affected, in other words, through mycotoxins, through spoilage, the particle size. The silages play an enormous role in protein metabolism. Rumen pH plays a very decisive role in protein metabolism. So understanding rumination and how it affects, especially the points in blue there, is significantly important in terms of protein metabolism, but actually, the total metabolistic situation of the feed that is going into the cow. Next one. Okay, lack of rumination or limited rumination is an early indicator of stress or illness. So actually being able to identify lack of rumination gives an indication that that the cows are not comfortable, that their stress is there, and there's either stresses or they're ill. And that needs to be taken into account. Otherwise, all your dietary preparation, or your formulation, or your purchasing of your ingredients, mixing a TMR, etc., and so on, really can be undone simply because of the stressors or the illness that will be that can be identified by identifying the cow is ruminating successfully or not ruminating successfully, and that becomes a very, very, very important process in the management of the cow. And normally, the stressors that will come from the lack of rumination are shown as the presence of mastitis or lameness or acidosis or bullying, and this provides a good measurement for the management to look at. Next slide. Okay, in any situation, any dairy farm, the body condition score plays a significant role in terms of when you walk onto a farm, how well the animals in that farm are being managed and looked after. And actually, the body condition score plays a significant role in understanding the way in which that cow has minimal stress or no stress and is part of the production process and producing milk. You are never going to get milk, high milk production from an animal that has a body condition score, a low body condition score. Now, there are two methods, but globally, method one, where a score of 1 to 5 is the main method, is used. And body condition score should be used as a management tool. In fact, as a consultant, when you walk onto a dairy farm, the first thing that you look at while you're talking about the weather or, you know, sort of how the farm is, you are assessing the body condition score of those animals, because that gives you an indication as to, one, your diet, your formulation, your protein metabolism, your carbohydrate metabolism, etc. And you can actually tell a lot from looking at the body condition score and from the cow comfort points on whether that farm is being managed well or not. Okay, next slide. So this is just a very quick slide. I won't spend much time on it, but normally with the body condition score, and I've used the one from Elenco, which shows the picture, and you can look at it as a visual from the back and from the side. Realistically, you need your cows to be between, your milking cows to be between 3 and 3.5. If you can manage your milking cows to vary between 3 as a low and a 3.5 as a high, you are maximizing your dairy cow's opportunity to produce milk. And therefore, it's important that you use this as a tool. Now, other way to do it is you have scales somewhere on your farm, and you regularly run your cows over the scales, and that will give a more accurate position in terms of looking at the weight of the cow and understanding whether that cow is gaining weight or losing weight, depending upon the situation. So the two ways you can do it, if you don't have scales and you can't run your cattle over those scales on a regular basis, the body condition score system is the next best. Okay, next slide. Okay, so the formulation, which the major components is energy and protein, and so we need them for the production of the dairy cow. Now, a number of the requirements will change on genetics, on activity, and that normally has to do with the farm and how it's managed, the body condition score, the cow size, the stage of pregnancy, and milk production. So taking those into account as the major points, there are other minor points, but the 6 major points is that we need to understand what that is in terms of what the requirements are for energy and protein. So having one ration for a dairy is really not conducive to good management. So microbial protein can sustain milk production as it is when the cow is producing 12 to 15 litres per day. All the protein that is produced from the microbial protein will go into that production. Normally, those cows have poor genetics. They're walking significantly. They have a lower body condition score, and there's a number of factors that then lead to those cows only producing 12 to 15 litres per day as an average. As milk production picks up, greater than 15 and say less than 20, there is a requirement for rumen degradable protein and undegradable rumen protein. So we'll talk more about that on the next slides. But as you increase and go up in terms of, the cows producing greater than 25 litres per day requires formulated levels of degradable and undegradable protein. And we'll talk about that. But the main thing actually is to understand that in a protein meal, in a silage, in a grain, there is rumen degradable protein and there is rumen undegradable protein, which will pass through the rumen and be digested in the hind gut. Understanding how much rumen degradable protein or rumen undegradable protein is in each of your ingredients is very important in the formulation process. Okay, next slide. So when formulating, we need to take into account many things. And I've only mentioned a few here because it's really impossible to talk about all the things. But the first thing I look at when I'm formulating a diet is actually the water that's available. And then you need to take into account the carbohydrates. In other words, the starches, the sugars, the soluble carbohydrates, the lignans, etc. So not wanting to read through all those as much, you look at the individual ingredient that is available for use in mixing. And normally there are a number of websites that you can check your ingredient against in terms of the general type of specification. So, for example, I use a number of different websites, including Dairy One out of the US, which you can go to, and it's a free website. There's also feed tables. In a lot of the formulation software, for example, the ones out of the Cornell University or ATMS, etc. Those have libraries attached, and in those libraries there is the general specification of the types of carbohydrates, or starches, grains, proteins, protein meals, etc. that you can look at. Now, really, the only way that you can look at your individual ingredient is actually to do some testing in a lab. Now that can be done wet chem or can be done by NIR, and that becomes a very important process of how often you do that, when you do that, and how that goes into the formulation. So most people that are actually using formulation software understand and know how to use this, and it's important that they actually do a check between the formulation software libraries and what they have as their ingredient going into the feed by testing that ingredient. For example, whether it's a soybean meal or a sunflower meal or a canola meal or DDGS or whatever it is, and then looking at it. So what is protein and what does protein do in the formulation? Okay, next slide. Yeah. Okay, so very, very quickly, protein into the rumen can be a true protein and can be rumen degradable, as we've mentioned earlier. It can be rumen and part of it can be rumen undegradable. So a percentage of a true protein meal can be degradable and a percentage of it can be undegradable. We can also have, as part of the protein formulation, non-protein nitrogen, and that can be an ammonia source or a urea source, and an inorganic source of protein. Okay, next slide. Okay, so as we get a little bit more in detail, we actually have the crude protein and the NPN. And now in the rumen, NPN will get broken down by the bacteria, the protozoa, and the fungi into ammonia, which will then get utilized into microbial protein. So there's a whole action that is going on in the rumen. Now, the biggest issue that I have is making sure that the rumen is a safe environment for the fermentation, for the breakdown of the all the feed that is going into the rumen. If you don't provide a safe environment and the bacteria, the protozoa and the fungi are affected, and hence their multiplication process is affected by either pH or by acid issues or by alkaline issues and so on. What we have up there in terms of the rumen making microbial protein, and hence the availability of microbial protein, as we spoke about in a few slides earlier on, being available for the cow, that doesn't happen, or it's significantly reduced. So what we're looking at then is how the protein is utilized in the animal. Now, some is absorbed in the rumen. Some of the true protein will go through into the abomasum and the small intestine, but the rest is taken into the blood and is put through and absorbed into the blood into the liver. And the liver is the main distribution network. And in the blood, if you have excess nitrogen, you also have a problem. And many dairies, actually, when you walk in, you can smell the ammonia that is coming through the urine. And straight away, you know that there is an issue with the feed formulation. Now, my biggest issue actually with being able to smell urea as soon as you walk into a dairy farm is two things. The high ammonia content in the urine gives rise to two practical things that the cow will have a problem with. One is it will physically show distress through respiration and through watering coming from the eyes. It will have an increased respiration rate, and hence that causes stress and will decrease food intake. So having an excess ammonia in the urine because of the diet that you're feeding, you actually are affecting your cow's intake of food, increasing the stress and decreasing your milk production. So therefore, we need to look at why that's happening and how that's happening and how you can amend that. Okay, next slide. Okay, some examples that we spoke about, and different labs, different types of protein meals have different levels of crude protein, of degradable rumen degradable protein, and different levels of undegradable rumen protein. And of course, not all of the protein in undegradable protein is absorbed by the animal. Some, of course, will be put out as in the feces, and that also depends upon the feeding rate and how the animal is being fed and how long the passage of the feed going through the animal will last, whether it will be in the animal for 6 hours, 8 hours, or longer. The longer the resident time, as long as the rumen has a more neutral pH and all the other factors in terms of fibers and so on is reasonable, you will get a higher level of breakdown of undegradable protein in the hind gut. But the main point of this slide is to show that of the crude protein, for example, if we take brewer's grain, 40% of it is degradable in the rumen, but 60% is undegradable in the rumen and passes through the hind gut. How much of that 60% then is absorbed, and how much of that 60% of the brewer's grain of the undegradable portion is passed out as feces depends upon the formulation and the cow comfort. So what I'm trying to get back to is the cow health in terms of its comfort will influence how much of the protein, how much of the carbohydrates, the starches, etc., absorbed, how much of the fiber is broken down and absorbed, and how much is not. So the influence in the management of the whole cow, including the cow comfort, influences how much of the protein, how much of the fiber, how much of the carbohydrate is absorbed. So in all those protein meals up there, you have different amounts of degradable and undegradable protein. Now, the higher the heat treatment that will be attached to the production of a protein meal, normally the higher level of undegraded protein is available to the animal. So if we take the two soybeans there, one is just a soybean meal without heat, and the other one is a soybean meal which has been heat treated. And you can see the higher level of undegraded protein in the heat treated source. That's important in your formulation software to take that into account and to understand if you are feeding reasonable levels or significant levels of heat treated or not, or not heated heat treatment soybean meal, because you can miscalculate on your protein levels by not understanding that. Okay, next slide. Okay, the protein production in the udder. So we've already sort of been through quite a bit in terms of the diet, the ammonia, and the blood. And so what actually happens as a rule of thumb, 60% of the protein will come through the rumen, through microbial protein, and into the blood. 40% will come through undegradable rumen protein, and hence will go into make milk and improve the body condition score. So that's just a very quick rule of thumb, 60-40. So if you have very limited undegraded ruminal protein, then you are dependent significantly on the microbial protein, and therefore you then will not have enough protein that will go through the blood into the udder to make milk proteins and to improve the body condition score. So milk protein is produced from amino acids and glucose. So the complexity of proteins is not just protein itself. In the animal, the whole diet is important, and how that interacts with the fibers, with the carbohydrates, especially the glucose, and how that works in the blood in order to then be passed on to the udder in order to make milk and mix with lactose and the milk proteins in order to increase the milk production. Okay, next slide. Okay, so the digestive process in a little bit more detail is what I was talking about then in terms of the fiber, the starches, the NPN, the rumen degradable, the undegradable, and the fats. Now that's basically what is in a diet. And if we look at it, we haven't really put the detail in terms of the fiber, in terms of what is NDF, ADF, etc., and also to the fats, which is bypass fats or non-bypass fats and the food additives. But the volatile fatty acids play a role in the rumen and into the blood in terms of the acetates, and then the glucose, the amino acids, and so on. But ultimately, in the udder, all those interact, which is fed from the bloodstream, which is then fed from the rumen and from the hind gut, from the amino acids and the small intestine, to deliver milk fat, to actually provide the body condition and growth, milk proteins, and therefore it becomes important understanding how the diet will affect the growth of the animal and also to the amount of milk that it's produced. Okay, next slide. So milk protein and lactose production are related. Glucose in the blood is needed to produce both lactose and milk protein. High energy diets, well formulated, produce more rumen microbes and hence more propionate. The propionate then converts to glucose and hence more lactose and milk protein. Higher fiber diets produce less and produce more acetate, and acetate will will convert to milk fat. So it's very, very important understanding what you are putting into the diet, how it will affect the animal in terms of the higher fiber versus enough fiber for a rumen to operate, and the requirements in terms of energy and protein must be balanced in terms of the rumen in order to for the microbes in the rumen in order to produce microbial protein. Okay, next slide. The precursor for milk composition is talking about the different volatile fatty acids in terms of the fat in the diet. Basically will produce milk fat. The carbohydrates in the diet will basically produce milk lactose. The proteins in the diet will basically produce milk proteins. However, there is an interaction between all of them, between fat and carbohydrate and protein for the fats, the milk lactose, and the proteins to be produced. But it's still important that you actually understand what you are feeding in terms of the ingredients. Okay, next slide. Okay, protein requirements during the lactation period. And this is very important that you understand that the protein requirement does not stay the same through the dry, through calving, through early lactation, through peak, through mid lactation and late lactation. And if you look at the feed composition there in terms of the down the bottom, and you look at RDP, UDP, and crude protein, you can see that there is an increase requirement for protein as the cow is calving in peak yield and down through to mid and late lactation. So it's important that you understand that there is a changing emphasis in terms of the amount of protein and a changing emphasis in terms of RDP and UDP. And hence understanding that and understanding the ingredients going in is very, very important to satisfy your cow's position in terms of its protein requirement, because in turn that will give rise to body condition score and hence gives rise to milk production. Okay, next slide. So protein is typically measured in terms of feeding as a crude protein. Now, nitrogen can be added and normally is a multiplier by 6.5. I'm not going to go into how that happens, but if in a later date we can. But proteins, in terms of how it's measured, if you measure it going in, the true protein is made up of amino acids, of peptides, dipeptides, nucleic acids, ammonia compounds, and which is also made up of urea. So it's important that you understand that the true protein is made up of a number of those different components. Okay, next slide. Now, the dairy cow uses amino acids for production of enzymes, immunoglobulins, blood, in the blood, milk proteins, muscle, and various organs and so on. So amino acids are not just going to make milk. Therefore, the requirement is significant in terms of the cow's activity and what is going on and whether that cow is growing, whether that cow is putting on weight. This needs to be understood in terms of the formulation process, because without enzymes, and I haven't actually put hormones there, but without enzyme, without hormones, without all the different components that the amino acids are used in the cow, the cow cannot produce enough milk, and therefore it's important that you understand that. But it is important to understand that excess amino acids can be used in gluconeogenesis and lipogenesis. In other words, if we have excess protein, amino acids for proteins and amino acids, they really can be used in other processes. In other words, gluconeogenesis is the production of glucose and fats. So it's important that we understand that. And therefore it becomes very, very important in their biological processes. Okay, next slide. This is important that we understand that amino acids, there are many different types of amino acids, and there are normally we consider there are 10 essential amino acids, with the remainder, and there's many of them, being non-essential. And therefore it's important that we understand, the 10 essential amino acids. So for example, most of the farms throughout US, throughout Canada, throughout Europe would use silage, corn silage and corn grain, and will also then use soybean. Now, there are significant important aspects of using corn and soybean. Okay, next slide. So corn is known to be deficient in the essential acid lysine. Soybean, methionine. So therefore, if you're using corn and soybean, corn grain, corn silage, and soybean, straight away you have a limiting process of the lysine and the methionine amino acids, depending upon the milk production. For example, greater than 25 liters, you actually have a limitation, and therefore you need to formulate this in order to increase the level of lysine and methionine in the cow's diet, and that can be done through a bypass product. Okay, next slide. Okay, so I think we've been through this one, and I'm running over time, so we'll go to the next slide. Yeah. Again, just mentioning, microbial protein is produced from rumen bacteria, protozoa, and fungi. And it's important that we understand that bacteria is a major component, but protozoa and fungi also play a role in the rumen. And it's important that we actually understand the components of the rumen that will enable the bacteria, the protozoa, and the fungi to process and make microbial protein. Okay, next slide. Okay, a list of the essential and the non-essential amino acids, and there's many more non-essential amino acids that I could have listed, but we didn't. So the two that we spoke about already is lysine and methionine, and we've been through those. Histidine is also considered a limiting amino acid for milk production in high-producing dairy cows. We are still doing work on that, and I think that really becomes part of where some research needs to be done. Currently, the main ones that we are supplementing as a bypass effect is lysine and methionine. Okay, next slide. Okay, so it's in terms of the formulation process, very important that we actually look at metabolizable protein. Crude protein can be done, but actually it is limited in its ability in terms of feed formulating. Metabolizable protein is a more accurate way of representing what is going on and how the diet will affect milk production and body condition score, or the weight of the animal. Okay, next slide. Okay, it's commonplace on large farms. We look at the performance, the reproductive. So for cows, it should be separated into high groups, medium, and low producing groups, and most of us do that. And therefore, the formulation should be for a high group, for a medium or a mid production group, and a low production group. The area that we actually neglect is the dry cow and the transition cow. And the stresses that come on in terms of the dry cow and because she's pregnant, and the transition cow is significant. And I'll give you one example. For example, vitamin E in the transition cow just prior to calving drops significantly because of the oxidative processes that is going on. Most of us do not compensate for the low level of vitamin E that drops in that process. If we were to compensate, it would give that early lactation cow a better start in terms of its immune response. So there are a number of things that we could talk about in another webinar that we can talk about why we actually do have different requirements for dry cow, for transition cow, for high, medium, and low milk production groups. Okay, next slide. Okay, now this one is important to show you why it is important to feed protein. In the table, we have milk production at 25 and 54 kgs. We have dry matter intake, which is related to which is related to body weight, but it's also related to milk production. So we increase our dry matter intake by 10 kilos from the 25 to the 54. The energy level, the megacalorie per kilo of each of those dry matter intake from the 25 is required at 1.37, and it increases to 1.61. It's an increase, but it's not as significant an increase as a metabolizable protein. The animal, in order to produce 25 grams, is required at 1.862. To produce 54 liters is almost double. The energy is not double, but the protein is double. And the biggest increase is in rumen undegradable protein. And you can see that in terms of, the figures that are there if you want to look at it and study it and so on. Understanding why that is and how that is very, very important. And therefore you can formulate in terms of the metabolizable protein in order to compensate for what is required for that animal's biological processes in producing milk and maintaining a relatively the body condition score will drop slowly, but hopefully we can slow that down so that it's minimal. And the secret of that is a metabolizable protein, especially the rumen undegradable protein. Okay, next slide. So here's just a table to look at for those of you that look at, okay, the crude protein, because I think many of you still, well, you may formulate on crude protein, and looking at what is required in terms of the metabolizable protein that is required in terms of the formulations, from the large size breeds to the small size breeds. It gives an indication depending upon the milk production and what is required in terms of crude protein versus metabolizable protein. Okay, next slide. So in conclusion, the efficiency of RDP is recovered as microbial protein. And that's important to understand, is that in the rumen degradable protein is recovered as microbial protein. And it depends upon the rate of the microbes, which also depends upon the formulation, so that the formulation is not creating an environment in the rumen which is acid or alkaline, and therefore would interrupt the normal processes in the rumen. So it's important that we understand what is happening, and we formulate for the dairy cow depending upon its position in the herd, whether it's a dry transition or milking. Amino acids can be supplemented, and it can be, in the main form is in the rumen protected form. Okay, last slide. For high-producing dairy cows, if the formulation provides sufficient nutrition for the high-producing dairy cow, typical rations, we would normally include the protected amino acids, the lysine, methionine, at a 3:1. That's what we have found in terms of the research that will give the best cost-effective position with the feeding of the amino acids, especially for the high-producing dairy cows. So we found that we actually get an increase in milk production of a couple of litres a day, increased components, the cow comfort. The cows are happier because of the digestive processes, and the stressors seem to have gone. And we can reduce the undegraded a protein, we can replace a percentage of the undegraded protein with a slow release urea, which we can talk about in another webinar.